Hey guys, welcome. Yeah, so example 2 here, and I strongly recommend that you watch examples 0 and 1. Yeah? Okay, cool. But otherwise, let's get started here. We know that we start by factoring the denominator, and it's pretty easy factoring here. We know that n squared plus n factors as n times n plus 1, and so we put n here, and then we put n plus 1 here, right? And since this is linear, that is, it's in the form mx plus b. It's just we're using the variable n instead of x, and m is 1, and then b is 0, right? Okay, but it is linear in form, and so then, and of course I'm allowed to use n instead of x, but yeah, since this is linear in form, as I said in example 1, when the denominator here is linear in form, we put a constant for the numerator. So we assume that the numerator must have been a constant on top of this denominator. And likewise, since this is linear, we assume that another constant here must have been on top of this denominator. So I say another constant because we already have this constant on top of this denominator. And this is n, not u. Okay. Anyway, we put a plus sign here, and then now we try to make this here look like this here, which would mean we need to first work on getting common denominators here. Yeah. So the process kind of reverses, if you will, in this step, because we first like factored, and now we're like kind of unfactoring, if you will. Okay, cool. So we do n plus 1 here, and then n plus 1 here, right? And then we do, important to have the parentheses here, n here, and then n here, right? And we see that now this equals, and we can turn it into one fraction since we have common denominators. And notice that this denominator, which is the same as this denominator, is the same as this here, n squared plus 1. So that's our common denominator. And so we go, okay, so we have division sign and n squared plus n, right? And then our numerator is a times n plus 1, and then plus b times n, all right? Okay, cool. All right, now we need this to equal this, and this was our bridge intermediate step, right? Okay, cool. And since this denominator is the same as this denominator, we only require that this numerator be the same as this numerator. So that means that now we're worried about 1 having to equal a times n plus 1, and then plus b times n. Now, and I didn't need the parenthesis around n, but I could also have it. Okay, anyway, and I'll actually have it, b times n. Yeah, okay, cool. Now, in the previous example, I told you that once you get to this step, there are two divergent paths you could take. One of them is a lot of algebra, the other is clever. And so here, I'm going to assume that you watched example 1, so I'm just going to show you the clever thing to do. And the clever thing to do is, since this equation has to hold true for any value of n, strategically pick n values. So for example, if we let n equal 0, then first the left side will still be equal to 1, and then because there's no n to plug into on the left side, right? But on the right side, we'll have a times 0 plus 1, so that's just a, and then plus b times 0, so there is no b. And that's why we chose n equals 0 as opposed to any other n value, because we knew that this was going to turn into 0. So you see, we immediately get to the value of a is equal to 1. And then if we let n equal negative 1, then again, on the left side here, there's nothing to plug n into, right? So we just write 1 for the left side. And then on the right side, we have, since this time n is equal to negative 1, we get a times negative 1 plus 1. And so that's a times 0. And that's why we chose n equals negative 1 in the first place, because we knew it would make this 0, right? This whole thing turned to 0, we knew. All right, so a times 0, so that's nothing. And then plus b times negative 1. So that's negative b. And so we have 1 equals negative b, which means that negative 1 is equal to b. So this is a very efficient way to get to the value of a and b. The other way to get there is to do algebra, right? In other words, to distribute this a here and the b is already there, and basically compare coefficients of the left side and the right side. And actually, since I've already kind of said quite a lot of it, I'll show you that other option. Although I wanted to make you watch example 1 to see that other option. But I think a lot of you like already figured out what I'm talking about. But if you chose to not pick n values, this is the other thing you could have done. And this is the other option I gave an example 1 after this step, which is next to write 1 equals, and then to distribute on the right side the a and the b is already distributed. It's only one term, or it's only one thing that's being multiplied to. But anyway, an plus a and then plus bn is what you'd have. And then if you collect like terms, you can write that you have an plus bn, that n. So you could write an plus bn and then plus 8, right? Okay, cool. Furthermore, you can write that you have a plus b times n plus 8. Now, to make it easy to compare this to this left-hand side, you could write this left-hand side as 0n plus 1. That's not on. That's 0n, 0 times n. And so then comparing this here to this here, it's clear that a plus b, which multiplies n, must be 0. So we see that a plus b must equal 0. That equal sign must equal 0. And we see that this constant here must equal that constant there. So a must equal 1. So first, if a must equal 1 and a plus b must equal 0, clearly b must equal negative 1, right? And that's what we found. A is 1 and b is equal to negative 1. We found long ago using the clever option. So that's why, like, you know, I choose the clever option, because why would I want to do all this algebra, right? All right, maybe you like all this algebra, so I don't know. Not gonna stop you. Okay, now what do we do next? Well, we're done, because what we're after is being able to write this as a over n plus b over n plus 1, and we figured out what a and b have to be. So we see that this fraction here can be split into two fractions, and instead of fraction I should say rational expression. But yeah, you get it, you get what I mean. So this rational expression can be split into two rational expressions, one of which is 1 over n, and then plus the other is negative 1, which is b over n plus 1. Obviously, instead of writing this kind of cumbersome thing, if you so chose, you could have put a minus sign here and then written 1 over n plus 1 over here. Yeah? Okay, cool. This is it for example 2, and the rest of examples all the way to 7, I'm not going to show you both the algebra and the clever method. I'm stuttering. Sorry. Tired. I'm only going to show you the clever method going forward. Yeah? Okay, cool. All right. I hope you enjoyed this. You can keep watching. Take care.